Question 5. So for part A, we've got to simplify this. So we start off by factorising the numerator of the denominator of the second term, x minus 2x plus 3. We can then aim to have the common denominator of x minus 2x plus 3 if we choose to multiply top and bottom by x minus 2 within the first term. So this is really gets us going. So we've got a common denominator now. If we multiply out the top and gather our terms, we get this, which simplifies to this. We can then factorise the numerator, giving us this. The x plus 3 factor then cancels from both, giving us what we needed of x plus 1 over x minus 2. Now we're trying to find the range of g, so really the y values that g operates over, given that x is greater than 3. So think about it, well, x is approaching 3. I mean, it's approaching 3 from above because x is greater than 3. But as we get closer and closer and closer to 3, we're going to be having 3 plus 1 on top and 3 take away 2 underneath. So 4 over 1, which is 4. So as x approaches 3, our y values, our function approach 4. Now think about when x is massive. When x is massive, when it's approaching infinity, we've really got effectively infinity over infinity, which is 1. So as x gets very big, our y values are approaching 1. As x gets very close, as our y values get very close, as x gets very close to 3, our y values are getting closer and closer to 4. So our range of y values, they're greater than 1 and less than 4. Never quite reaching 4, never quite reaching 1. Now for part C, we've got to find the exact value where g of a equals the inverse function of a. So let's start off by working out the inverse function of a. So really we're changing the subject. So we let y equal x plus 1 over x minus 2 and follow through the algebra in order to make x the subject, which I've done here. We then of course rewrite it in the appropriate format with the variable being x. So our inverse function of g is 2x plus 1 over x minus 1. Now we're trying to find the value where g of x, so x plus 1 over x minus 2, equals our inverse function of g of x, tx plus 1 over x minus 1, which we've got here. So multiply both sides by x minus 1, x minus 2 gives us this. Multiply out the brackets gives us this. Gather our terms and set it equal to 0 gives us this. This does not factorise, so we use the quadratic formula, giving us x being 3 plus or minus root 13 over 2. However, x is greater than 3, so it's got to be the value coming from when we add on to 3. So our exact value of a is x plus root 13 all over 2.